Here's an overview of all the variables you need to know for a wave, and we will briefly cover each one in this video to make sure to stick around until the end. This is specific to chemistry. Let's start with amplitude. This is the maximum vertical displacement from our axis of propagation. These points all represent the wave at its amplitude. It's a max separation from the x-axis, whether above or below. This brings us into money points, which are simply all the points along the wave where the height is either at a max height, at a min height, or at 0. Now, there's nothing formal about money points, but identifying them will help you solve more difficult wave problems when they for sure will come up. Next up, propagation speed. And remember, since we're dealing with light, this is simply the speed of light, which is 2.998 times 10 to the 8 meters per second. This is something to memorize, which is very easy to do with flashcards or simply doing lots and lots of problems with waves. Although a wave oscillates up and down, ultimately it propagates its signal horizontally, in this case, left to right. Wavelength is the horizontal distance it takes for a wave to repeat itself. It could be the peak-to-peak distance, it could be the trough-to-trough distance, and beyond, as long as the two endpoints have the same height and have the same slope. Describing a wave with a wavelength requires us to model that wave in terms of distance, hence right here. Period is the horizontal distance it takes for a wave to repeat itself. It could be the peak-to-peak distance, trough-to-trough, and beyond, as long as the two endpoints have the same height and the same slope. My explanation for wavelength was literally the exact same thing, only for period, it's with the wave in terms of time. Likewise, frequency is very similar to period. Firstly, in that they are both time-related measurements for a wave. Frequency is simply the inverse of period. While period is the time it takes for a wave to complete a full cycle, frequency is the number of cycles a wave completes in a fixed amount of time. If, for example, our period is 5 seconds, due to the inverse relationship between these two variables, the frequency would be 1/5 seconds inverse. Intensity is a little unique. It's essentially a measure of how concentrated light waves are when they strike a particular area of space. The greater the number of waves per unit of space, the higher the intensity. So as you can see, these are very smushed together, so this is a higher intensity than these are. Another indicator of intensity is the amplitude, where a bigger amplitude means a bigger intensity and a lower amplitude means a lower intensity.